Hello, and welcome to this video on designing and editing GDS files. In this video, we'll be having a look at the Search and Replace feature of KLayout. This feature allows us to search through the various shapes and cells in our layout based on a set of conditions that we define. Once those shapes are identified, we can apply some basic modifications to them or replace them altogether. This seemingly simple concept is actually very powerful for editing your pattern and can make your life a lot easier. To start, I have a pattern here with a couple different shapes already drawn, and as well as a few cells. What we're going to do is open up the Search and Replace function under Edit, Search and Replace. This menu here is divided up into a few tabs that can do different operations, such as just searching, deleting, replacing, and even custom. We'll go through them one by one to kind of get a sense of what's going on. First is Find. In this menu, we can decide what kind of objects we're looking for. If we look for an instance, we're looking for different cells in our layout. And if we look for shape, we're looking for all of the boxes, polygons, paths, and text. The shape is kind of an overarching handler for all of these other objects below. We can get more specific, or we can search for them in general. So if I select shape, I can then specify what cells I want to look into. Do I want to look at all the cells, this cell, or the cells below it? So we can specify different parts of the hierarchy. And then we can specify more of the search parameters here. We can specify the layer, or even the area or perimeter, and we can say larger than, equal to, different kind of comparators there. If I go ahead and search at this point, it's going to throw me a list of the objects that it's found that match these conditions. If I select one of the objects there, the software even zooms in on and shows me where that object is in my layout. If I go to text here, you'll see it's going to select the text at the bottom of this layout. This is really handy for finding something like these small dots that I drew here that wouldn't show up otherwise, or may not be visible otherwise, but when we do this search, we can easily see where they are in our layout. The next tab here is the Delete tab. Same kind of interface, only this time when we run this script or this menu, we're going to be deleting the objects. So in this case, I'm going to actually delete the text. As I mentioned in the past, most lithography tools cannot expose GDS text elements directly. So if you have them in your layout, you might want to delete them so that you don't cause an error when you get to your lithography tool. If these are hidden in some cell that you might not be thinking about, this is an easy way to search through your entire layout and delete them in just a few clicks. So here I'm selecting text in all cells, and I'm going to not specify a layer or any of these other parameters to just search for everything. If I just do delete all, it's going to delete it without prompting. If I do just select and delete, I can at least see the objects that I'm deleting before I delete them. So again, this is that one text object at the bottom that I can just delete with this button, and now it's removed. If I had text in any other cells in this entire hierarchy, it would appear when we did this search. Next is Replace. This is similar top part of this where we're defining the conditions that we want to search for, but in the bottom we now have some options on how we want to replace what we found. For each of the different objects that we can search for, like text or polygons, there's a different set of replacements here. With the text, for example, we could actually change the content of the text. So we could change it from saying one word to saying a different word, or change the orientation or the size. I'm going to go ahead and look at the shapes again here. For shapes, we're kind of limited in our options. All we can do is to change the layer. But that can be useful. Let's say I have some shapes that are very small that I want to move to another layer. One reason I might want to do that is in lithography tools, we often want to separate out different size shapes that are kind of orders of magnitude different in size, either just expose them on different tools or using different conditions in a single tool. So in this case, if I want to say find all these very small things and move them to a new layer, I could specify the same kind of very small parameter here, and then I'll say a new layer. Whoops, new layer here. Let's make that layer 5 with data type 0 and click OK. And now I'm going to do again this select and replace so I can see what I'm going to replace first. So it's showing me these few boxes. Again, these are these kind of 9 little boxes that I hid in the top here. And those are the 9 entries here, so that looks good. So I'm just going to replace all. And right away you can see it's changed the layers of those so they're now on a new layer. Very handy for doing that kind of globally across your whole pattern in just a few clicks. The real power of the search and replace function though is the custom function, custom queries. And KLayout is hinting at that at the bottom of each of these pages. It's saying for more, much more use custom queries. we go jump over to this custom tab here. It's actually very nice in that it takes whatever you just did. So here we're running this replace of the small things in layer 1 to layer 5, and it's filled in this text here that will do exactly that. So this is a great way to learn how to write out these custom queries, is to write something first using the kind of GUIs in the other tabs, and then switch over to custom queries to see how the software is implementing that. So just kind of reading this almost as text, we can see that it's saying with the shapes on layer 1, from cells star, where star is a wildcard, so from all the cells, where the shape.area is less than 2 microns squared, now the shape.layer is layer 5. So that kind of makes sense, even just reading it out, as to what we did in the replace. We're going to look at these a little more to see how you can write them on your own and understand exactly the syntax of what's going on here. Before we do that, I'm going to break this up a little bit just to make it a little clearer. So let's add a few carriage returns here. And do. So the way that this is broken up is in kind of a layered structure. And I will say all the info that I'm going to talk about here is in this click for more details section here. I'm going to try and cover it simply here so that you can get an idea, but if you want to really learn more, that's the best place to look. The way that this is set up is kind of in a layered structure. There's the core of your search, and then you kind of wrap layers around that to do more with the search. The center of the search is always a cell. So in the middle here, we have the cells star, and then wrapped around that, we have the shape search on either side. It's kind of selecting what type of shapes we want to look for, what layers and what additional conditions we want to apply. And then lastly, the whole thing is wrapped in an action, the with, and then do the shape.layer change. So let's break down each of those things to kind of see exactly what's going on. Before I do that, I'm going to save this, this current search just so we can pull it back later. This bottom part here is a nice handy feature where you can save things. You can see I have one that I use all the time, which we'll talk about later. But let's save this current one. If I click the plus, I can enter the name. So this is my replace small with layer 5. Roughly what it's doing. Now, if we ever need this in future, we can just load it without having to type it all in again. So let's break this down. Let's remove these outer parts of our search and just look at the cell search to start. Now, if we run this, it's going to find all the cells in our layout. Specifically, it's looking for this entire hierarchy here, so you can see all this stuff on the left here that I laid out just to make it interesting and give us a bunch of cells. You can see them all on the left there. The star here, as I mentioned earlier, is a wildcard. So right now we're searching for every single cell in our entire layout. If we want to be more specific, we can treat this just as text. Let's say we want to find all the cells that start with the letter M. If I do M followed by a star, that's the letter M followed by anything. So that's like searching with any cell that begins with an M. If I now run this, you can see I've pulled up different cells that start with M, and they're from different places in the hierarchy because we're searching through everything. Very similarly, if I do star, say S, I'm looking for anything followed by an S. So this is going to be all the cells whose names end in an S. If I run that, very clearly I get these 3 that end in an S. And lastly, for these searches, if I wrap the letter in wildcards, then I'm searching for anything with an S and then anything, so that's looking for things that contain an S. If I run that, I get a whole bunch of different cells that have an S in them. All of this syntax is kind of analogous to kind of SQL syntax, so if you want to learn more, you can try that. This particular cell stuff where we're looking at these texts with wildcards is very much like regular expressions if you want to look more into that. In addition to searching for the letters of the cells, we can start to search in the hierarchy. We use dots to specify different levels of the hierarchy. So if I just put a single dot here with the same star, S star, it's going to look for cells in the first level of the hierarchy that contain an S. So in the first levels of the hierarchy, all we have is device and solar system. So when I run this, only solar system contains an S, so that's the only thing we see. Let's go ahead and expand this back out again. And now we can say, what if we do this S and then another star? This is going to look for things in the first hierarchy level that contain an S, and then then in the next level of the hierarchy, any cells. So this is going to be all the cells that are children cells of the solar system. So in this case, planets and sun. Execute that. That's exactly what we see. Notice that this one is not specifying a letter here. So It doesn't matter what letters these subcells contain, only the parent cell contains an S. And so we can kind of mix all these things together to specify exactly where you want to in the hierarchy to do your searches, and what kind of letters or words you want in the cells that you're looking for. So let's go back to just the standard star, and let's actually pull this back up so we can look at the next kind of layer in our search here, which is the shape query. And I'm going to remove the second line here. So this first part of our shape query is saying, inside of cells, we want to look for all the shapes on layer 1. So shapes on layer 1 from all the cells is another way to think about that. So if we do this now, we're going to start pulling up all the shapes on layer 1 from cells. So this is pretty straightforward, I think. We can modify this beyond what we could do in just these tabs. In those tabs, we were limited to searching for just a single layer or all the layers. We can go beyond that here by specifying, oh, I want to look for everything in cells 1 through 5. Then we get a bunch more returns here because I have a lot of objects in those other layers. We can even use commas to separate things. I could look for everything in 1 to 3 and also in layer 5. So this time we're skipping layer 4 and we lose a few of our shapes there. So really a lot more you can do here by kind of specifying things explicitly with this custom queries. We go back to this, let's look at the other half of the shape query, which would be the shape condition. That's on the second half of this. So again, we're kind of wrapping around the cells search with this shape query. Here we're specifying a condition, so where the shape dot area is less than 2 microns. So this is going to significantly reduce the number of things, and actually is nothing because you remember earlier we moved all the things in layer 1 over to layer 5. So let's just switch that so we can see something there, and there's our result. This shape dot area here, the shape that we're using depends on what we search for. So if instead I'm looking for text and I looked for text.area, that wouldn't really make any sense. The text isn't going to have an area. To know kind of what you should be looking for, you should really look through the KLayout help. So if I would just jump over here, let's open this assistant for the custom searches. And from there, we can search in the search box for anything we're interested in. So let's look at the shape real quick. The API reference for class shape or class whatever you're looking for is what you want. And here it's going to list all the different methods that you can apply to that object. So example, here we're looking at area, and it says returns the area of the shape. There's a bunch of things here. There's the perimeter. Anything you can use here, you can probably use in this search. Just make sure you're reading something, not setting something, or else it might not work. So really useful tool to look through here, see kind of what things you can use. And you can string things together. We could say where the area is, maybe we'll say greater than 2 microns. And I could say, and shape.perimeter is greater than 1 micron. Something like that. And so we can combine things here. We could also have 2 conditions. We only want the area between 2 and 100 microns squared. We can tie all those things together with the ands in this conditional part of our query. So then the last part of the custom queries in general is the action. So the first action that we looked at here was this with do syntax. So with these shapes in these cells, with these conditions, do this action. And again, those actions, we're going to be looking at that API reference to see what exactly we're working with. So if I look here for layer, it says layer returns the layer index. Oh, I want the layer equal, moves the shape to the layer given by the layer index object. So that's exactly what we did. We moved those things that were too small before into layer 5. So that should hopefully make sense. Now we can do other things though. We could say, let's look for everything that's kind of in a range. So maybe we'll say, and shape dot area is less than, sorry, greater than, we'll say greater than 2 microns, excuse me here, and less than maybe 500 microns squared. And we're going to do here, let's do, instead this time, let's do shape.polygon. So this is going to be the polygon type object that we're searching for. We want it to now equal shape.polygon. And we're going to round the corner. So if you looked in the previous video where we talked about some of the things that we can do in edit, so in edit selection, we could round corners. That's a function that we can use in the search as well to actually do something. So let's jump back here. We're going to round corners. I'm going to say something really big so we can see it. And I'll specify the number of points is 64. We execute this. We did not specify something quite right here. Let's say 5,000. Yeah, and so now we've just rounded the letters of the text here without affecting the square here. So the square is much larger than 5,000, but these p_cell.text, the area is less than 5,000. So it gives us a way to conditionally apply these actions across our layouts. And here, this layout is fairly small. It would be simple to just click the individual things, but if you start to have many, many components, this can be very, very useful. So that's the with do action. The other action would be delete, which we saw earlier. This one is just prefacing it with delete. And just like in the delete tab, it's going to delete any shapes that match these conditions. The last one that I wanted to show you, and the last one available, is select. With select, you can see the results of these different conditions that you're applying. So you can select shape.area from some conditions. So let's just remove this and execute. Oh, whoops. And of course, it needs select shape.area from shapes on this and matching this condition. And now we're seeing the area of everything that matches this condition on layer 1. And again, I can string things together here. I can say, show me the shapes themselves and shape.area. And you'll see the shapes here, and way over here on the right, the area. So you can match up one to the other and see how those things correspond. This is really useful when you're kind of troubleshooting this, trying to set up your custom query. You can see what the area is returning, what these different parameters of the classes return, to then better define your search. One thing I will point out, one that's very common, is when we're defining this, we specified the unit here. Because in general, we're using the database unit of the layout for these searches, so it could be nanometers or something very small. That's why these areas are gigantic, because there's a huge bunch of kind of trailing zeros behind them. Instead of using shape.area, we can use shape.dArea, and the D version of these functions returns the parameter in the unit of microns. So if we run that, and now jump over to the right, you can see these have been reduced by a factor of 1,000 or maybe even 100,000 to make them in units of microns rather than the database unit. So it makes them a lot more readable and kind of more what you're familiar with when you're designing these patterns. So that's a really useful thing. The last one I want to show you is this custom query that I use all the time. So let's go ahead and load this one up. Here I'm using select again, and I'm doing searches. And what I'm searching for here is I'm searching for the cells that are named mark. So what I want to do here is I want to look for my alignment marks. So when I draw patterns, I'm often making alignment marks around them to do alignment in lithography tools. And here I've created an array of marks. So these 4 crosses in the corner. And when I define this, I made an array. So it's just a single mark that's arrayed. When I want to go to my lithography tool and find the coordinates of this, if I double click on one of them, I'm only going to get the coordinates, the position of the cell origin here, of the bottom left cell, because that's how I defined my array, was to kind of go up and to the right. So it's only telling me these coordinates. I could use the row and column vectors to then kind of calculate where my other mark centers are going to be. But if I didn't use nice units here, or I had a lot of marks, it could be a lot more math than I might want to do. The other option would be to put my mouse over the marks and to read the coordinates down here in the bottom right corner. But again, that might not be so precise if I didn't use nice round numbers. So what this search and replace does is not actually replacing, it's just searching, but it's looking for instances of cell marks. So that's where all of my different instances of this cell are that I've named mark, or you could change that mark specifier to whatever you might use for your alignment marks. And then I'm selecting the instance bounding box, which is giving me the bounding box of those marks in the coordinate system of the layout, which is what I want. It's finding the center of that box, and it's telling me the x coordinate and divided by 1,000, again, to convert us into microns. There's unfortunately no D variant for this particular action or this particular function, so we have to divide by 1,000 to get microns. And it's telling me the x and the y coordinates, so the coordinates of my mark. If I execute this, and jump back over to the left here, execute again, so it's giving me a terribly formatted cell where the x and y are way split over on the left and right, but you can indeed see It's giving me the X values here and the Y values here for these 4 marks separated by 2000 microns. I can show you with the mouse here at 1000 minus 1000. So yes, that's the search and replace function. There's a lot of power here that we can do with these kind of simple search and replace. The things we can't do are compare objects together or kind of add them up, things like that. That's something we have to do with macros, and that'll be the subject of a future video.